All right, so part 2 of chapter 9, phylum Arthropoda. So these are the arthropods. They're the most successful group in this kingdom, in the kingdom Animalia, sorry. 75% of identified species fall in this particular phylum. They've got a molting exoskeleton. It's made of protein and chitin. Chitin just like fungi, right? Their cell wall is made of chitin. So, for fungi. So interesting story. A long time ago, I had this reef tank, and I had this red and white banded shrimp, and it was really cool, just really pretty, also known as candy cane shrimp, and really pretty. And one morning we came in and we found him dead, and we're like, oh my gosh, like that's it, he died. We had no idea what happened to him. Next thing we know, later that day, we saw him. We saw a second one. We went, oh my gosh, he fell. Like, oh my gosh, he multiplied, and then we realized he had molted. That first shell that we saw, the molted exoskeleton, was so perfectly intact. That's why we were so certain it had died. It is truly, when they molt, it is, I mean, every part of the animal is perfectly intact. It's really pretty cool. They actually are divided into segments. They've got joint appendages, and they've got a very good, pretty good, not as good as your cephalopods, but still pretty good, developed nervous system. You've got two main groups, the chelicerates and the mandibulates, all right? We're going to talk about both those separately. Your chelicerates, these guys are obviously your horseshoe crabs. Got a good specimen for those. All right, this is your primitive groups, your spiders, your ticks, your scorpions, all fall into them. Obviously, the ones we're going to concentrate on, the marine ones. They have 6 pairs of appendages right here. Okay, your horseshoe crabs have 3 body regions. The cephalothorax, that's a fusion of both the head and the thorax. The abdomen, the belly. All right, and then the telson, the long spike, they use that to actually flip themselves over. If you've seen horseshoe crabs upside down alive, they will fold themselves in half this way. So this part will come up, so they can get their telson stuck into the sand, and so they can flip themselves over. It's really quite interesting. The carapace, males tend to be smaller than the females, and they've got the chelicerae, which are these modified oral appendages that they use to go ahead and eat. They technically, they don't have true mouth parts. So I've got this specimen right here for you. Right here, this is where the eyes would be. Okay, really nice long telson, right? The belly, part of it is still there. Right, here you've got the appendages still left. We've unfortunately lost the mouth parts, not the mouth parts, sorry, the chelicerae. But, and then right here, where the abdomen is, that's what moves, and that's how they can actually swim. So, right here, and there's these different little layers, and they have little hairs on them. Right here, I don't know if you can see that, you can still see remnants of little itty bitty hairs right there. They're pretty cool. I've got that small one that's in this jar. I don't know if you can see him swimming around. I don't know if you can see him well. All right. And he's just a little baby one that we had. Another teacher gave me. It's very sweet. So, cool. All right, you've got sea spiders. They have 4 or more pairs of legs. They can be found anywhere from the intertidal zone to 6,000 meters. Remember, that's about 18,000 feet below sea level. They're especially common in the polar regions. Males will carry the eggs. They'll feed on juices from the cnidarias. The C is silent. Cnidarias, those are the jellyfish. We're going to find out about those in chapter 8. And some other soft-bodied invertebrates. They're using long sucking proboscis. Remember, proboscis is just a type of nose, a long tube-like structure, nose-like, if you will. Now we've got the mandibulates. Your marine mandibulates, subphylum Crustacea. Mandible appendages used for chewing their food. All right, you've got 3 main body regions. You've got the head, the thorax, the two together to make the cephalothorax, and then you've got your abdomen. There are appendages. They've got a pair of appendages for every body segment. They've got 2 pairs of sensory antennae right there. Mandibles and maxilla for feeding, and then the swimmerets right here. know if you can see it. Hopefully you can see it well on your PowerPoint. The swimmerettes, I love them. I love them. They'll use that to swim around and move. They're really cool. And slipheads are very, very important as well. And see the little hairs right there? They're cool. So they still also have telson, just very, very different than the long telson that we have in the horseshoe crab. Right? We've got crabs to look at in better detail that I will have again in dissections if we're not able to do them in person. So the swimmerettes, if you have the opportunity to look at some shrimp up close and personal before you eat them, there's your swimmerettes. Those are the little appendages that are in the back end of the shrimp. Cool? When you see them molting, they'll come out head first, and then the rest of the body will come behind it. Then we have the decapods, deca for 10, right? So they're going to have 5 pairs of walking legs. That's your crabs, your lobsters, your true shrimp. The tulipettes are claws. They have huge, huge range, in size, anywhere from, you can have some, the giant crab that's 13 feet tall and 40 pounds, like right here. You've got a giant crab standing up, pulled out, next to this man, 40 pounds. North Atlantic lobster was a meter long, 3 feet, give or take, weighed 42 pounds. Hermit crab, of course, this is a very elegant looking crab. And then, of course, the very typical blue crab, which can often be found in crab cakes. I just recently found that out, I didn't know that. Common blue crab is the most agile swimmer, kind of cool to know. Decorated crab, these guys are hilarious. Decorated crab will actually sit there and grab other things to put it on its back. It can grab a sea urchin, it can grab a sponge, it'll throw it on its back and walk around with it so that it hides, and it's camouflaged, all right? And it's kind of like, oh, no, you don't see me, I'm not a crab, I'm just an enemy, I'm a sponge, anything else. It's really kind of cool. And then, of course, hermit crabs will actually go and find empty gastropod shells. Talked about gastropods, snails, right? So, shell like this, and it'll grab it, move into it, and take it to its new home. Nutrition and digestion, they use their chillipests to capture prey, and they're basically scavengers. So, the most expensive thing that we can find for seafood, i.e. lobster, crab, they're scavengers, i.e. they eat dead stuff. So, kind of an interesting little fact. When it comes to reproduction, you can actually identify whether you have a male or a female based on their abdomen. The male will have this spear-like appendage right here, whereas the female has more of a curved, what I think of as a basket, and it's truly to hold the eggs. That's where it goes, right there, okay? Males have modified appendage, or spermatophores. Remember, that's what holds the pockets of sperm. Copulatory pleopods, that's right there. Most will brood their eggs, that means that they hold them. The larval stage will be the zoea. Look how pretty that is. I just think it's so pretty, right? That's the first larval stage. And then the nauplius larva, that's the second stage. So it'll go from an egg to this, to a crab. Kind of cool. Crab and lobster. Mantis shrimp. Very, very, very cool shrimp. No, you don't want to eat them. No, you don't want them in a tank. Good friend of ours had one in his tank. It cracked the glass. These guys can move their claws at such speed that they can boil water. I have a video for you to watch. Okay, so it's a series I think you guys might be familiar with. They have a lot of really great videos. The language is definitely college level language, so put your headphones in. I apologize for the language, but it's really, really good, and it's really cool, and it's really hilarious. So I apologize, but it's really informational and really good, but it's really cool. So watch it, but make sure your headphones are in. Specialized predators, they've got a second pair of a thoracic appendage, and so yes, so he had it in his tank, and it literally cracked his tank. They're extremely strong. You don't want them. They're not good for eating, and you don't want them as a pet. Okay? Absolutely not. Krill, main food source for our largest baleen whales. They are filter feeders. Most are bioluminescent. The photophore, specialized organ that makes them bioluminescent, they'll be in swarms, so large masses. Right there, you can see them. They're almost translucent except for the photophore part, that bioluminescence. Pretty neat. They're pelagic, of course, so they're in the open water column, anywhere from 3 to 6 centimeters long. Reference point. So 3 to 6. All right. So perhaps a little bit bigger than you thought. All right. Amphipods, class Amphipoda. These guys are lateral compressed. They've got 3 pairs of appendages. They're towards the back. These guys always remind me of roly-polies. This right here is what gray whales eat. Remember I told you gray whales were one of the few whales that actually dove down and scooped up a bunch of ocean floor instead of filter feeding for the krill. They actually scoop a bunch of ocean floor. That's what they're going for. They're going for these amphipods. All right. These guys are burrowers or tube dwellers. They are scavengers or detritus feeders, so feeding on dead things. The young resemble the adults as soon as they're born. Beach flea also fall into this category. Copepods, the largest group of small crustaceans. You guys remember when we've been cleaning out the tank? We often found little copepods. I miss you guys so much. We found little copepods in the tank and the filtration systems, especially with the carbon filters. We'd find little copepods swimming around. These guys, the largest group of small crustaceans, the most abundant of the zooplankton, so not phytoplankton, but zooplankton. So these guys are what feed off of the phytoplankton. So they are on the second trophic level. Mostly suspension feeders. Males use spermatophores again. The eggs are shed and hatched in the water column. Barnacles. They are sessile, the only sessile crustacean. Sessile means they are not moving. Right? So these guys will latch onto a hard surface. Their shell is made of calcium carbonate. I did not bring any down. I'll see if I can find some real quick. They'll filter feed using cirripeds. So there's these little feathery appendages that'll stick out, and they'll catch any kind of food. They are hermaphroditic, but they will also cross-fertilize to have better gene pool. All right. Of all the animals on the planet, when you look at body, penis size to body, we're looking at the barnacles having the largest penis to body length ratio, right? So barnacles are awesome when it comes to penis size. There you go. The cirripeds right here, you can see them. I can see them right here. You probably can't see them. Thank you so much. My mom's helping me out with the videos. There we go. So right here you've got a really cool barnacle. I don't know why I took it to the screen. Right there, right? That's a barnacle shell, really pretty purpley pink, right? Barnacles, right? We've all seen that. We're good. You got these extensions right here. Cool. If you can't see them off the camera, please look at the PowerPoint. The Nauplius larvae will develop into the cyprid larvae, so you'll see a lot of similar larval, again, supporting that common evolutionary background. This one is a little different. This is a new one. We haven't seen this one before, but you still see a lot of overlapping, especially with the larval development, which is pretty cool. Arthropods, they're an incredibly important source of food. Obviously commercial fishing of lobster, crab, and shrimp. They are symbiotes, so cleaning shrimp and their stations for a lot of fish. You've got ecto and endoparasites for fish. Barnacles are commensalistic. So remember, commensalistic where it's positive and no impact. So positive for the barnacles, no impact on, if we're talking about whales, the whales are on, Again, that's actually in debate right now because we've seen whales that are in poor health will have a higher barnacle growth on them. So we're not so sure it is commensalistic. That's being called into question. But for right now, since we're not sure it's not commensalistic, we're still leaving it as commensalistic symbiotic relationship. The role of arthropods in recycling and fouling. So fouling means that you're harming the ships or the boats, the bottom of the ships and the boats. Huge problem. The speed of badly fouled ships can be decreased by 30%. So the increased drag on a ship by the barnacles can be diminished. The speed of the boat can be diminished by 30% because of the drag caused by barnacles. That's what I'm trying to say. Good? All right. Getting there, guys. 23 slides left. Arrowworms. These are pretty to look at. They're very carnivorous, very voracious feeders. 4 to 15 grasping spines that are just these curved hooks that they'll use for prey. Almost transparent. It's crazy how pretty they are. They belong to the phylum Chionotha. The GN is pronounced. The G is silent, and it's Chionotha. All right. Sorry, Chionotha. All right, echinoderms. That's your sea stars. I will still call them starfish. But sea stars, sea urchins, and sea cucumbers, they have bilateral symmetry. I'm going to explain bilateral symmetry in just a second. Bilateral symmetry means there is only, I've got to cut them this way, right? I cut them this way, I have two halves. If you cut me down the middle, I'm going to have two halves. If you cut me across the belly, those two halves don't match up. But if I cut down here, I'll have two halves. If I cut here, I'll have two halves, right? You've got to cut them in specific areas. That's bilateral symmetry. Radial symmetry is what the lower invertebrates are going to have, and that's chapter 8. We're going to talk about that a little bit. Bilateral symmetry will have in the larval stage. I'm sorry, you guys. Bilateral symmetry in the larval stage, radial symmetry in the adults. So here we can cut them through in multiple areas. That's your radial symmetry. I knew something was off. All right, we can cut through multiple spots, but with us, we can only cut in one way. But their larval stage only have bilateral symmetry. That's where we start seeing that we're getting further into the connection between the higher invertebrates and the lower invertebrates. Okay, and echinoderms means spiny skinned. And if you see our starfish or sea stars, makes sense, right? Right here, they got spines on them. And here's a sea urchin. You can see the spines on that. If you notice, starfish, sea biscuit, and you can really see it in this one. You notice the pattern. There's 5, right? You see that 5 star on all of them. That's a distinct pattern of echinoderms. Their endoskeleton is made of plates of calcium carbonate, and they have a vascular water system that supports how they're moving around. So remember we talked about the tube feet that our starfish has? So the tube feet are the little feet right here, that our sea urchin also has it right here, and here. Right, the little feet, that's what allows it to move along and allows it to open up that oyster to get to the food. So right here, those tube feet. Well, how in the world are they able to get the pressure they need to function? Well, it's thanks to this water system that they get through this itty bitty opening right there called the madrepore. So the starfish sucks in water through that one opening, and that water gives it the water pressure to control all of the tube feet, the thousands of tube feet it has inside the entire starfish. Or on the belly of the sea urchin, or on the bottom, see every single one of those little holes? That would be where the tube feet of the sea biscuit would be found. Sea biscuit is super, super thin, paper thin. I mean, I could just, a little more pressure and this would crush in my hand. All right. Tube feet, the technical name for them is podia. Podium, singular, podia, plural. So here we go. We've got nice dissection right there. Picture the dissection, and again, we'll have dissections of those. Sea stars, they have a central disc with 5 or more rays, depending on the species. 5 is the minimum. And here's an interesting fact. In nature, if you take a starfish and you break off an arm, the arm will regenerate. You probably knew that. What you might not know is if you take a starfish and you break off an arm, please don't go out and do this, but if an arm happens to break off with part of the central disc, right? So let's say this whole section breaks off, you'll end up with 2 starfish. This will regenerate, and then that arm will actually grow 4 more arms, and a whole second starfish will grow. But if that happens in captivity, this arm will grow back. But that arm, even if it has part of the central disc, this is the central disc up here, that'll just die off. Don't know why. There's obviously something that we cannot reproduce in captivity, and it will not let it actually grow into a second starfish. They've tried multiple times, it won't work. All right, the aboral surface, the opposite of the mouth, is typically rough and spiny, right? Aboral, okay? Feeding in starfish, they're carnivorous or scavengers. We talked about this. They'll go around, open the bivalves, invert their stomach, and release, insert it into the bivalves, digest them. For reproduction, they can regenerate their rays about 1 every year. Most will have separate sexes, and sperm is released into the water again. Ophiuroids, they are benthic with 5 spiny arms. They're brittle stars or basket stars or serpent stars. That's what we have in our tank, you guys, is a serpent star. The red one that we have, and then the 2 striped black ones, they are serpent stars. It's pretty close to ours. It's not quite him, but it's pretty darn close to him. All right. They're 2 feet, lack suckers. That's why he's able to wrap around the food and bring it down. Oh, by the way, we fed him yesterday, and woo, he was hungry. That's the one. Those 2 black ones we have that are striped. That's right there is exactly what we have. That is what we call a basket starfish or sea star, basket sea star. Had one of those a long time ago in the old tank. He climbed out and went into the pipe system and got himself stuck. They are difficult to keep alive, especially in captivity, to say the least, but very, very pretty. And this is not an exaggeration. That is pretty close to what ours look like. All these little tentacles, but they easily break off. And they will also easily break them off to go ahead and feed the predator that's trying to get to them so they can escape. Otherwise, cast off ox predators around. So basically a way to protect itself from predator. Asexual reproduction by division. So cut themselves in half to go ahead and reproduce. Sea urchins. Their body is enclosed by a hard exoskeleton. Sand dollars also have the same setup. It's kind of like a hedgehog, if you will, right? You've got these spines going, just like our starfish, our sea urchin. Our sea urchin spines are getting so long, you guys. Like, I kid you not, at least that long. Those spines are movable. All right, so this past summer, and I've got it saved in my Facebook of when it was. I want to say it was the 2nd or 3rd week of July. We went to Fort Clinch, that beach that's right next to where the old pier was. We went to the water, and I kid you not, we probably found about 20 live sand dollars that all had orangey yellow coloring on them. Okay, first of all, I had never before found 1 live sand dollar. Yes, I know that's pathetic, but I hadn't. So never mind finding 20. We were like, what the heck is going on? And then we kept finding them covered in this yellow string on them. What we realized was they were in the middle of releasing their gametes. So obviously it was the right tide, the right temperature, the right everything, and it was a good old time for them. So our hope is that our beach will be open by then, and we'll be able to go. So if you guys happen to go to the beaches then in July, keep an eye out. Fort Clinch, like I said, the beach, the calmer beach, that little alcove area, right close to where the pier used to be. I kid you not, about waist deep water. You just feel around and you will feel them and you pick them up. And the sand dollar, here I've got some right here. The sand dollars are obviously when they're dead, they're white, but when they're alive, they are a beautiful, when they're sad, when they're dead, they're white. They're like this really pretty clear color. But when they are alive, they're really, really dark brown. Like you feel them more than see them. So right, we got our little sand dollar right there. Okay, and we were finding sand dollars about that big. They were big. This one's a little thicker, kind of neat. And there you go. Again, we see that 5-star pattern on the top. Very, very, very typical of echinoderm. These guys are grazers. They've got the Aristotle's lantern, and it's a feeding structure that is going to be found on the bottom. Okay, when we do the dissection, I'll make sure to point those out to you. And there's 5 little plates that come together and allows them, as is, so imagine my hand is Aristotle's lantern, sea urchin, he's moving along and he grazes on the algae. That's another reason why. So in freshwater tanks, you might have the suckerfish, Plecostomus. In saltwater tanks, you have sea urchins. They sit around, they gnaw. Only problem is that little Aristotle lantern can gnaw so much, it can actually scratch up the inside of your acrylic tank. They're kind of known for that. Deposit feeders, it just really depends on what they're eating. Okay, there you go. There's that Aristotle's lantern. All those plates come together, kind of like a little claw. It's really neat. 14 slides to go. Ooh, there's a video at the bottom. Don't forget to look at it. Sea cucumbers. These guys have respiratory trees for gas exchange. All right, so that's right here. There also is some of the more colorful sea cucumbers in tanks. Also, again, very hard to keep them alive. You'll see them have that. You might not have noticed them if they're more of a less colorful sea cucumber. But the very colorful ones, they'll usually have bright color on them. And they'll pop, that's it right there. And that's where they're having their exchange. Let's go ahead and breathe. Very simple structure. These guys, in order to get away from a predator, they're known to spit out their guts through their mouth. And so their entire digestive tract will get spit out. And it's kind of like, okay, you want to eat me? Fine. Eat my digestive tract. As I inch away, and they'll just slowly move away. Right here, they've got these little extensions that they can move along. And the predator will typically eat the intestines. And then the sea cucumber will regrow, regenerate those entire intestines, and survive. It's really kind of neat. It's a great, great way to get away from predators. Best behavior, Cuvarian tubules from the anus release to distract the predator, or can viscerate, which is the releasing of the internal organs. Crinoids. Feather stars or sea lilies. They are sessile with grasping cirri, so these are hook-like structures for clinging. These are the most primitive of the echinoderms. They're suspension feeders. They can regenerate their lost arms. Again, hey, you want to eat me? Go ahead and grab one of my arms. I can regrow it. No big deal. These are very, very pretty. Now, you're going to see a video about the crown of thorns. The crown of thorns has become a huge problem in the Pacific Ocean on the western side of the United States. So remember we said starfish, sea stars, can have more than 5 arms. As you can tell right here, you're talking like good 15 to 20. Okay, crown of thorns are a big problem. Please watch that video and learn more about them. Sea cucumbers, some of them can be poisonous, but that poison might actually be beneficial as medicine, as to for tumor growth suppressor, to stop the growth of a tumor, cancer tumor. There's so many ecological roles with these guys. Just obviously food. Sea urchins will eat the kelp. Crowns could be a problem. Crown of thorns could be a problem to corals. They're causing huge devastations on corals when they're not kept in check. Okay, when they are in check, so again, everything being in balance, they're a good thing. Just right now, with that particular region, they are out of balance. Section 8, hemichordates. Phylohemicordata, these are acorn worms. They are sessile. They burrow in the sediments. They've got a large proboscis, nose-like structure. used to dig burrows. Section 9, invertebrate chordates. All right, the 4 most important characteristics, the 4 characteristics that make you a vertebrate are having a notochord, having pharyngeal gill slits, having a postanal tail, and having a dorsal hollow nerve cord. Every single vertebrate has these 4 characteristics at some point in their life. I'm going to say that again. That means that we had a postanal tail at some point in time. We really did. What do you call the thing you sit on? Your tailbone, right? You say if you, God forbid, ever fell on it and you cracked it, I cracked my tailbone. Because past that, you had a tail. All right? That postanal tail disappeared very early during development in the womb. We have all 4 of these characteristics. We had pharyngeal gill slits also during very early development. Those gill slits disappeared, but we had them. These 4 characteristics right here. All right, I actually missed that bell, I can't believe it. Those 4 characteristics right there are truly the separation between invertebrates and vertebrates. You need to know these by heart for the test. Yeah, know them. 4, know them, please make sure, okay? Tunicates. They're mostly sessile, so phylloeurochordata, widely distributed. They're named for their tunic, body covering of cellulose. These guys are sea squirts, scalps, larvaceans. Sea squirts, I got a cool video for them. It's super simple. They've got a siphon to let water in and a siphon to let water out. Water goes in, they filter feed, and the water goes out. And in the video, the guy messes with them and they shut closed and they squirt the water. It's really cool. Very, very simple structure. Again, we are getting into the simpler and simpler animals. Right? We started with the most complex, we started with our mammals, and now we're getting simpler and simpler, making us appreciate the simplicity. Okay? You got a more close-up picture, sorry. Here we go. There's that video I'm telling you about. Budding occurs in colonial abscisians. Most are hermaphrodites. Here's that video. Budding, that simply means you copy yourself, and you've got a second one, and it buds off, breaks off, and floats away. That's how sea squirts reproduce. Again, we're getting simpler animals, so we're going to reproduce more simply. Everything's going to be more simplified. Really cool little video. Please watch it. It's not long at all. All right, salps and larvaceans. We've got your tunicates, your free-swimming tunicates, and then this free-swimming larvation right here. I don't want you to fret about these guys too much. And cephalochordates. That's your lancelets. I've got a really cool slide. I will do my very best. If I can't get a good picture of the slide, I will find you a good picture on the internet.